So I'm going to balance this complex half reaction. The oxidation states are written in. So hydrogen doesn't change. +1 to +1. I move to nitrogen is +5. And it doesn't drop to 0. It drops to +2. So that is a +5 to +2 is 3 electrons. Then I want to write down how many electrons are transferred for the whole thing. The H does nothing, the nitrogen does 3, and the O is -2 on both sides. The O doesn't do anything. So it's only the nitrogen, 3 electrons. There's 1 nitrogen. So HNO3 will transfer 3. The other change is the arsenic. It's 3, and again, not to 0, it's 3 to 5. So 3 to 5 is a difference of 2. 2 electrons for every arsenic. Then I want to know for that whole reactant, hydrogen doesn't do any, oxygen doesn't transfer any, every arsenic is 2, and there's only 1 arsenic in the whole reactant, so that'll be 2 for the whole thing. Then I can balance the electron exchange. The lowest common multiple is going to be 3 times 2, 6. There's no lower repeat than that. So I want to double my first reactant to get 6, and I want to triple the second reactant to get 6. So I've balanced the electron exchange. This is by far the hardest part. This is the bulk of the new skills. Then we're balancing atoms other than O and H. So I've got 2 nitrogen. So I need to have 2 nitrogen at the end, just the law of conservation of mass. For AS, I've got 3 times 1 at the beginning. So I'm going to need 3 times 1 at the end. So that's the electron exchange. That's the O and H, non-O and H atoms done. Then I have to balance oxygen next. And I have a lot of oxygen, so I definitely would want to use a visual aid and not try to hold this in my head. I've got 2 times 3, which is 6. I'm not done, but I want to get that visual down. 3 times 3 in my second reactant. 9 more. So that's 15 between the 2 reactants. I've got oxygen all over the place on the product side. 2 times 1 in the first product, and 3 times 4 in the second. That's 12. So in total, that's 14. So I'm short 1 on this side. That's my low side. I need 1 more. I want +1. So I'm going to put 1 water. And we don't write stoichiometric coefficients of 1. Last, the hydrogen. 2. And then 3 times 3 is 9. So we've got 11 in total at the beginning. At the end, there's none there. 3 times 3, 9. And then our water has 2 more. Oh, so that's also 11. So we don't have to add any H+. So this complex half reaction is balanced. The stoichiometric coefficients are 2, 3, 2, 3 with 1 water. On an exam, if they asked you to fill in a numeric response value for the water, 1 would be the correct number, even though we would leave it blank visually.